Hello, friends and networkers. Welcome to another episode of Networking with Sir Gadvin. We'll be discussing one of the most important topic in our computer networks, the IP addressing. And I hope at the end of the session, you may be able to understand what an IP address is. Okay, so I guess we are going to start. I'm going to share my screen now. Since we'll be talking about IP addressing, I would like to discuss also the scope so that we cannot go out of bounds with our topic. Firstly, we are going to discuss the concepts of IP addressing and determine how an IP address works. IP address has different parts. That's why we have to identify which one is which, so that when we will be working with an IP address, it's not only the IP that we are focusing on, but there are parts of which. So we also have to determine what are the classes of IP. And this is very, very important. And by the way, we are focusing here only on the IPv4, the IP version 4, because in other tutorial, I will be teaching you how to work on with your IPv6. We have also special addresses in the list of IP addresses that we have. Those that are paid for and those who are free. Okay, these are special addresses and some more. Here, I am going to teach you how to compute for a network address and a broadcast address. I believe if you are given a particular address and ask you if it is an IP or if it is a network, if it is a broadcast, I think you cannot really determine until such time you know how to compute it. Okay, let's start. An IP addressing is a manner of configuring the level 3 address of your network using the TCP/IP. And everybody knows what a TCP/IP means. It is a transmission control protocol / IP protocol. Only here you can put your IP addresses so that it can communicate with other computers. Basing on the OSI model, IP addresses belongs to the layer 3, specifically at the network side. So when you configure the TCP/IP protocol on the Microsoft Windows computer, an IP address, a subnet mask, and a default gateway is required in the TCP/IP configuration settings. And at the end of the session, teaching you how to put up IP addresses into your computer, and we are going to simulate it. So to configure a TCP/IP correctly, it is necessary for you to understand how it works and the address and the divided networks and subnetworks. So basically, IP addresses is not the only thing that we are going to understand, but also other parts of this address. If we are going to work on with our TCP/IP setting, so if you can see a little button there or a little icon that says network right side lower part of your screen, or sometimes it is a wireless connection, that is what we call the command in order for us to reach the TCP/IP settings. Click onto that, then go to the network sharing center, then look for the Ethernet LAN. Then afterwards, go to properties, then this option, the Internet Protocol version 4. So basically, opening that goes to this dialog box, and here you put your IP addresses. So once the IP addresses is being in place, you press OK, etc., etc., then your computer and the other computer bearing the same network here or bearing the same address with the same subnet mask and default gateway can now communicate. That's how we implement our IP address. But really is what is an IP address. So an IP address is a unique identity of an interface in an IP network. An IP address are just like postal address. No? When you are going to write a letter and put it in an envelope and you mail it, totally different from what you are doing because you are using emails now. So during our time, we are using postal. So in order to send and receive the package through the postal system, every house needs a unique postal address. So later I'll be explaining to you in analogy what this postal address is similar to an IP address. So in order to send and receive packets in an IP network, every interface needs to have a unique IP address. These addresses may sometimes be displayed in a decimal form, but the computer and the network processes it in binary form. That's why binary system or numbering system consists of zeros and ones are expressed in 32 binary bits divided into 4 8-bit octets. So that's why if our address is seen as 192.168.10.10, so basically that's you reading it. But on the side of the computer, it cannot determine what is that unless it will be converted into binary numbering system. So talking about interfaces, we have a network, and if you are going to send packet from one network, LAN to LAN B, and the target is PC number 2. So you are going to go through the interfaces. From this PC, you are sending packets or you're sending your information. You have to pass through what we call interfaces. These interfaces are found in your router. It's the G00 and the G01. Then also it passed through the switch, then PC2 will receive it, vice versa. Okay, imagine these IP addresses are very, very useful when determining a specific source and destination in your local area network. So here is the analogy between an IP address and a postal address. Let's say, for example, the area address of your place is Nasipit Road, Barangay Talamban, Cebu City, and your house address is the block number and the lot number. So means that this house number 1 is block 12, lot 10, block 12, lot 11, and block 12, lot 12. So all of these houses here belongs to block 12, but different house number. So if we are going to consolidate that kind of information, this house now will become block 12, lot 10, Nasipit Road, Barangay Talamban, Cebu City. Same is true with the second house and the third house. So it becomes an address now. I hope this is clear to us that when we have our address, every courier, the delivery system around the world can identify now where to deliver packets that you need, okay? Or the delivery of your items will be delivered correctly to your house rather than any other house because you have your address. Now, let's put that in an IP address. So imagine that this computer here are houses, and each house has an IP address, a house number, and a block number. So let's say the block number here is the network address of all the IP. Meaning these computers here belongs to one network and has a lot number, which is the .1, .2, .3. So that this area here belongs to one single place. It is masked with 255.255.255.0 as the area address. So it means that this is block 12, lot 10, Nasipit Road, Barangay Talamban, Cebu City. So again, the network address here is the block number where all IP address belongs in one block. Then to specify a specific house, it should be numbered. Depends upon the administrator. Where will he start? By .1, by .2, by .3, or by .10, .11, .12, as long as no two the same numbers in that particular block. So you cannot have .1 here and .1 here, or else the packet or the delivery man would have a hard time determining who is the owner of this package. Let's answer the analogy between your postal address and the IP address. Now, IP addresses has parts. You should identify what are the network part, as what I've told you, just like a block number. And the host part is just like a lot number. That an IP address it's a big number, a 32-bit number that uniquely identifies the host. It's either a computer or other devices, a printer or a router, or a cell phone. These are all connected via TCP/IP network. Now, IP addresses are normally expressed in dotted decimal format, with 4 numbers separated by periods such as 192.168.123.132. It's not 192.168. This is not an FM radio, okay? So we say or we mean 192.168.123.132. So no points. So in binary, 32-bit number is to be expressed in all numbers 1 zeros, 1 0, so on and so forth. This number may be hard to make sense, so it is divided into 4 parts with 8 binary digits. Like for example, if we are going to count 1, 2, 3, 4, 5, 6, 7, 8, and it is divided by a dot. 1, 2, 3, 4, 5, 6, 7, 8, then divided by a dot. Okay, 1, 2, 3, 4, 5, 6, 7, then that's a dot. So meaning, in this address, you have 8 bits, 8 bits, 8 bits. So 4 8 bits equals to 32-bit all in all. Binary notation is very, very important in computing IP addresses. You have to identify what will be the network part. The network part is always represented by what we call N. And for the IP address or the host part are represented by H. And the format is dependent to the classes of IP. And when we say format is the way your network part is written and the way the host part is written also. So take note that in a particular IP address, like for example, in an 8-bit IP address, last portion example, that is 2 raised to the power of h, meaning there are 8 zeros in that particular octet. So minus 2, therefore you can create about 256 IP addresses. Therefore, an h has 8 bits. So this is 256 minus 2. The minus 2 will always be there. That's why you can create about 254 IP addresses in a particular class of IP, like for example, class C. And take note also that network part is always 1 and the host part is always 0. So later we will have to identify what is the difference between the ones and 0 that I am telling you and the all zeros, which is equivalent to the H. So example of an IP address with its particular classes. So let's say, for example, the IP is 192.168.10.1. That IP belongs to network 10.0. And this network is a class C network. So another example, you have 158.12.0.38. According to the classes of IP, this is class B. And if you look at class B, this is an IP because the host portion of that address is numbered. And if you look at the network address, the two octets are 0. That's why the 158.12.0.0 is the network address of this IP. So it's very clear that IP belongs to a particular network, and this network is class B in nature. The other example is 11.0.0.200, and its network, and this IP belongs to this network, 11.0.0.0, which is a class C in nature. Another example, 180.200.15.105. What is its network address? So we mean that this IP belongs to somebody. That somebody is 180.200.0.0, and 180 is a class B network. That is an example of an IP and a network and classes of IP. But we have to dig more into this so that we can understand how this IP is being represented by classes. It says here in our table, IP address is class A, class B, or class C, aside from the format that you have seen. The usual thing that we can determine whether that IP is class A, B, or C, it's because of the range of the first octet. If you look at the end there, and the range is 1 to 126, meaning that is class A. If it is class B, the range of IP addresses or numbers you can see is 128 to 191, and that is also the first octet. And if it is a class C, the first octet is numbered 192 to 223. That's why, going back to our example here, this one is 192. We said that if the first octet falls on that range, since it is 192, it is in a class C form. Now, if it is in a class C form, you can now identify the format. Look at this. This is a class C. Why? Because the first octet is 192. So we know that the format is n.n.n.h. So we will take note that if all n's are numbered here, 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 and if the h is 0, it's a network address. But if it is 1 or any number you can find at the h, it is an IP. So in our example, that is that one. So meaning that's an IP. In this example here, 192.168.10.0, that's why the 0 portion is a network address. 158.12.0.38, is it class A, class B, or class C? Take note that 158 has a range here between 128 to 191, that is 158, so it is a class B. So if it is a class B, then look at its format. So the format of class B is n.h. And if you look at the number, if the two h's here are 0, it means it's a network address. But if any of the h's are numbered, whether this h or that h, as long as it is a number, therefore it's an IP. Okay? So for each classes of IP that we have, we will be using also what we call a subnet mask. A subnet mask determines how far are we going to stop numbering our IP address. If your subnet mask says, we will go to class C so that it will be simpler. It says there 255.255.255. That means that there is no number after 255 because all ones are already been used. So if we are going to use 1111111, that's 8 bits already. So are there any zeros to convert? No more. So if you're going to count 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1. So that's equivalent to 255 because you turn all of the bits now. Okay. So if the case is these are all 255s, 255.255.255.0. It is in binary form for 8 zeros, 2, 3, 4. So a while ago, we have computed already the IP address. So meaning we cannot change this one, but all zeros still can be changed. That's why you got 1, 1, 0, 1, 1, 1, 0, 0, 1, 0, 1. And you get the idea already. So we are incrementing the IP address. This is dot 1, dot 2, dot 3, dot 4, dot 5. So where will it end? It will end if all of the zeros becomes 1. So 1, 2, 3, 4, 1, 2, 3, 4. So meaning it's already close by 255 first octet, 255 by second octet, 255 by third octet, and 255 by fourth octet. So meaning there is no way for you to add some more because all the zeros have exhausted already. But in the case of class B, your subnet mask is 255, right? This one, 255, 255, 255, the 0, the 0. So that means you have 255.255.0.0. So if we are going to convert also the 0, the 0 into its binary form. So meaning that is 0, 0, 0, 0, 0, 0, 0, 0, dot 1, 2, 3, 4, 1, 2, 3, 4. So meaning this one is the binary form now. So take note, when we increment, this is 1, 1, 0, 1, 1, 1, 1, 0, 0, until all of this octet here becomes 1, 1, 1, 1, 1, 1, 1, 1, and this is 255. So will you stop there? No, because you are not class C. You get the point? Class C stops there because there is no 0 at this portion at the be incremented. That's why this one will become all zeros again. And the third octet increments by 1. Okay. So if we are going to convert that into a decimal form, your address now will become 255 dot, meaning 255.1.255. Okay, so you have exhausted the fourth octet, but you have incremented 1 at the other octet. So you have to exhaust all the zeros for you to stop. You cannot stop creating an IP as long as it is not 255 yet. That means this will become 255.255.255.255 for class B. So you have exhausted all the zeros because there are all ones now. If you are going to compute how many IP addresses did we created? Now, in this example, we just created at least this IP address, that is 2 raised to the power of 8, correct? Because we have only 8 bits there, and that is 256. And I told you that the first and the last cannot be used. That's why that's -2. So in theory, you are going to use only 254 IP address. Now, in class B, how many bits they created? That is 2 raised to the power of 16. Okay, and 2 raised to the power of 16 is 65,536 minus the first and minus the last, 65,534. So meaning in class B, we are creating about 65,000 IP address. Let's look at the class A. Class A says, if you'll notice that the format follows also the subnet mask. So N, meaning 255, all H's are 0. So if we are going to convert that and question or ask ourselves, how many IP addresses did we create? Okay, let's compute. So that is N, so 255, okay, that's 255.0.0.0. So that means that we are going to convert all of this in binary form. So this one cannot be converted anymore because it's already 255. Again, so 1, 2, 3, 4, 1, 2, 3, 4, dot. 1, 2, 3, 4, 1, 2, 3, 4, dot. 1, 2, 3, 4, 1, 2, 3, 4. So meaning we have the second octet, third octet, and the fourth octet. I hope you understand these things out. Now, incrementing is following the procedure also of class A, class C, and class B. If all of these are exhausted, that 1, that 2, and that 1, 3, 4, 5, 6, 7, 8, you exhausted it. So meaning the third octet will be incremented also while the fourth octet will become 0, then 1.1, 1.2, 1.3. Okay, then until such time, all of this will increment also. That is 1.255. Okay, we have to increment again. So since these are all 0, it will become 1, 0, meaning that is 2.0.000000001. So meaning that's 2.1, 2.2, 2.3, so on and so forth. So if all of these are exhausted as 1.1.1.1.1.1.1.1.1, we mean that our address is 255.0.255.255. Shall we stop there? No, it's not. Why? Because you still have the second octet to increment. So meaning that is 1.0.0, 1.0.1, 1.0.2. If it is 1.255, meaning this will become 1. If this third octet reaches to 55, then the second octet will increment. If the second octet increments to 255, the 255, meaning this one increments also until it reaches 255.255.255. Okay, so if you have all 255s there, then you stop IPing because there is no already zeros to be incremented. So how many zeros we have converted? How many zeros did we compute? That is 2 raised to the power of 24. So if you're going to compute that, this is about 16,777,216 IP addresses minus 2, which is the beginning and the end. You cannot use that. That's why you can create about 16,777,214 IP addresses. Okay. Take a look at these classes of IP. A class A has a network format of like this. Okay, has the first range of the first octet of 1 to 126 with the default subnet mask of 255. You can create about 16 million IP addresses. Then, for example, it starts with 10.0.0.0 and end with 10.255.255.255. So meaning your network is 10.0.0.0 because zeros are network, and 255, the 10.255.255.255 is the end point of how did you compute for the IP addresses. So all in all, you get 16 million. In class B, the same format. 2 ends at the first and second octet, where the first octet has a range of 128 to 191. That means this is a class B. Then the subnet mask also is similar to the format of your network address. Then you are computing about 65,534 IP addresses. Example, your IP address is 130. This is class B because it is in between 128 to 191. First octet only. Second octet doesn't matter. So 130.19.0.0. That means it's still a network because it's still 0. But if you are going to start incrementing by 130.19.0.1.2.3.4.5, you exhausted all the zeros of the third octet here, meaning it becomes 255. It goes back to the 0 again, but the third octet will increment by 1. So that's why it is 130.19.1.0, 130.1.2.0 until such time that the third octet reaches to 55. So it becomes 2 again. So 2.0, okay, 3.0, 4.0, until such time you are going to exhaust all the zeros here to become 255. So if it reached 130.19.255.255, that will be the last part of your IP address, and we call that one as a broadcast. Okay, now if we are going to count for the IP addresses in class C, the format is n.n.n.h. So meaning we are focusing on only one H here. So it becomes a class C if the range of the first octet is 192. Example, 192.16.10. This is a class C because the first octet is in between or in the range of 192 to 223. But if you take a closer look, the H portion at the last portion and this one will be incremented by 1, 2, 3, 4, 5 until such time it reaches the 255. Then it stops there. And the 3 octets here bearing the number 192.16.10 is already an N. So meaning it cannot be incremented anymore because it has been masked already with 255. So if a mask is 255, there will be no way for you to change this number. That is true also to the other classes of IP. If you have any question, put this up in the comment section, then maybe I can answer it as soon as possible. Okay, we are now at the special addresses. We know that aside from the IP address that we are using and the network and the broadcast address, we also have what we call special addresses. Special addresses such as 0.0.0.0. This is an IP address, but this type of IP address represents all networks. Okay, that's why it is 0.0.0.0 because there's no specific network there. So it represents all network. Now, the 127 is not also an IP intended for IP addressing, but this is intended for loopback testing. So that's why 127.0.0.1 is your local host. So I have mentioned already the 224 and 239, which is the class D used for multicasting, and class E used for future use. So basically we don't use this IP addresses. We are not going to use the 255.255.255 because it represents all hosts, means the broadcast to all. Those are the special addresses that we will not use when we are going to IP our computer. So we also have what we call public addresses, and what are these private addresses for? So take note that when you are going to work on with your IP addresses, we take note what type of addresses are we talking about here. Always remember that in each classes of IP, there are public and private IP addresses. The point of the public addresses are, these are addresses which are commercial in nature. So usually, these public IP addresses is given by our ISP or the internet service provider. So it's either we are going to pay for it or whether we are going to subscribe for it. And those are public IP addresses. So how do you determine a public and a private IP addresses? Any addresses from a range of 10.0.0.0 to 10.255.255.255, meaning it's a private address. And in class A IP address, we are not going to use this to become public. Okay, we are free to use this address inside our organization. So meaning if it is inside our organization, any private address is only inside. Okay, it cannot be routed outside. So meaning all computers only of the same private IP address can communicate with each other. But if the computer would like to communicate outside, meaning their IP addresses are not routable anymore. That's why there is a router there that you are going to send your packet to the router, and router will be the one to convert the message to become an IP, public IP address. We call it the network address translation. If you want to email somebody inside the organization, it's okay. But if you are going to email it outside, you are going to pass through the router first, convert that IP address to become public so that this email will be routable to the public. That's the idea of what we call public and private IP address. So when a person also emails you, they are using the public address, then it will be sent to your router and converted back into a private IP, which is intended for this person, which he is using a private IP inside. The question there is, why is it that we are going to use private IP addressing? Why not? If you are using this computer connected to the internet, you are subscribing for the ISP. ISP will give you public, and inside is your private address. That's why some of your IP addresses is 192.168.1.0, meaning this is that one. So you are paying for this. You have another router at home, another computer is connected to the same ISP, again, you are paying. This information here, or if your ISP costs you about 1,299 or 1,300, you are spending about 2,600. If you are going to use this format or this type of addressing, you have only one router with you, okay, and that router is connected to two PCs, and these two PCs bears the private addresses, and this is connected to the ISP. Take note, ISP gives you public address, and you have already the private address. So you are only going to pay one public address. while two of these computer is sharing that public address. So it saves your spending or your budget intended for your ISP or for your internet connection. So it would be very crazy that a company of 100 computers will connect itself to the ISP individually, rather than a good network administrator will only create an inside private address and one public address that carries all the private address when computers would like to go out from the organization. Just let the router convert all of the signal from private to become public and public to become private. That's the work of your router. And that is the idea of what we call public and private addressing. Always remember, any address outside of these private addresses are all public. As long as it is not 10, as long as it is not 172, and as long as it is not 192, it is considered as a public address. And these public address are maintained and regulated by what we call ICANN, an Internet Corporation for Assigned Name and Numbers. So basically, each of the continent is given a particular set of IP address, and somebody manage it. In the area of Asia Pacific, we call it the APNIC. Okay, you can look for it, research for it, so that you may know this public addresses is given by the Asia Pacific Network Consortium. I hope this is clear to all. Okay, example, I gave you an address here. That's 129.18.15.200. Now the question is this IP address private or public? So basically, all addresses that is 10 in nature, 172 and 192 are private. So that means that this IP is public. Is this an IP or a network? Then we can determine if it is an IP or a network if we are going to determine its format. So the format says n.h.h. The h portion is numbered, we call it the IP address. And if, let's say, for example, 192.168.10.0, is it a network or an IP? Take note that the format is n and h, and h portion is still 0. So if it is still 0, it is a network address. Okay. This is the more difficult question. If you are given an address, let's say 198.180.11.15.200. Question, what is the network address? What is the father of this IP address? That will be our next topic. Let us compute now. In order for us to identify a particular network of a given IP, we always compute it according to its subnet mask. So if you have an IP and if you have a subnet mask, basically you can get the result, and the result would that be the network address to where that IP came from. So the process of computation is what we call the ANDing process or the AND operation. So the AND operation is similar to the binary multiplication. Like for example, 1 and 1 is equals to 1, 1 and 0 is equals to 0, 0 and 1 is equals to 0, and 0 and 0 is equals to 0. If you are given an IP address, all you have to do is to convert it to the binary digit address and compute using an AND operation. That way, you can now determine what would be the result of that particular computation. Let's say, for example, the IP address given is 198.15.200.12. We know that this is a class C address, therefore its subnet mask is 255.255.255.0. Now, we plot all the binary in this manner, okay, to identify what is 198, what is 15, what is 200, and what is 12. So again, if you don't know how to do conversion, it would be a very disadvantage on your part. So you have to learn how to convert. By using now what we call an ANDing process, okay, we AND all each digit one by one. This is quite a task, but later I will be teaching you how to shorten your operation. Okay, for the meantime, this is what we're going to do. Okay, and 0 and 0 here is always 0. 0 and 0 is always 0. 1 and 0 is, according to our rules, 1 and 0 is 0. So meaning this is 0, 1 and 0 is 0, 0 and 0 is 0, 0 and 0 is 0, 0 and 0 is 0, and 0 and 0 is 0. So all of the octets here, all of the bits at the fourth octets are all 0. So about the third octet, this is 0, 0, 0, 1, because 1 and 1 is 1. 0011 dot. Okay, we go to the third octet, 1111, because all ones and ones are ones, but zeros and ones are zeros. Okay. Then same is true here, is 011 00011. So if you will notice that we are just bringing down all the numbers from the upper portion because it is ANDed with ones. So that means any number ANDed with 1, it is the same number. So this is still 198. And if you're going to compute the second digit, if it's still 15, 1, 2, 4, 6. So that you may understand, 1, 2, 8, 64, 4, 32, 16, 8, 4, 2, 1. So have turn on 1, 2, 3, 4 bits. And the rest are 0, right? So 1 plus 2 plus 4 plus 8 is 15. So the third octet is still 200. And the fourth octet is 0. That means that the dot 12 belongs to 198.15.200. That's 0. You understand? Another example. I hope you get the process. All you have to do is to look after the rules of multiplication or rules of ANDing procedure. So let's say 25.11.78.121. We are going to look for the network address of this IP. Where this IP came from. Since this address is a class A network, therefore its default subnet mask will be 255.0.0. Okay? So we will make this one a little bit shorter so that it would be faster. If a number is ANDed with all ones, it is still the same number. So meaning that is 000110001. Still the same number, right? And if that number is ANDed with 0, the answer will always be 0. Meaning these are all 0. Those are the rules. Now, 3, 4, 1, 2, 3, 4, dot 1, 2, 3, 4, 1, 2, 3, 4. So 1 and 0 is 0. 1 and if all numbers are ANDed with 0, the result is 0. If that number is ANDed with 1, the result is that number. So meaning this is still 25, that's 0, that's 0, that's 0. We mean that this IP address belongs to this network. So that is very easy of identifying an IP with its network. Another example, we have an IP address 190.25.80.19. We know that this IP address is a class B address. So we are thinking that its subnet mask is still the default 255.255.0.0. But in this case, the subnet mask is subnetted. That's why the third octet is numbered now. Look at this. The third octet is 0, but this time it is already 2, 2, 4. So will this network here, if it is not a subnetted, therefore it is very easy for us to say that this IP address belongs to this network 190.25.8.0.0 because the subnet mask says 0.0. But in this case, would be the same. Let's try. We converted the upper portion, the IP address, and the subnet mask is converted also with its binary notation. Take a notice now that is 255 all ones, 255 all ones, and 224 is 123. Then there's our 0. So 123 meaning 128 plus 64 plus 32, and that is 224. Now we do the AND. All numbers bearing ones are still the same number. 1 0 1 1 1 1 1 0 dot 0 0 0 1 1 0 1 1 dot 0 1 0 0 0 0 0 0 dot. Since these are all 0, automatically these are 0. Now let's compute. This one is still the number, no? 190 dot. Again, this number here, since we bring down that number, still 25. But that number here is we turn on the 64 part. So meaning this is 64. No other number is open. Dot 0. So that means that this IP address now belongs to this network 190.25.64.0. It is not 190.25.0.0. So meaning this is wrong. This is the correct answer. Okay. So I hope you can now determine if a particular given IP with a different subnet mask, does not result always to 0. It results to a different number, and look for that number. Let's say, for example, our address is 158.200.17.22, and its subnet mask is 255.255.248.0. We are going to convert all of this number into binary, but for me, I don't have to. And I say 158. Since our subnet mask is 255, the result will always be 158. All right, 200. Do I need to convert them to binary? Not necessarily, because it is subnetted mask with 255, the result is still 200. Dot. Since we have the next number of 17, okay, and we are going to convert the subnet mask there into 248. So this is quite a little bit difficult for you, but that's why we are going to jump to the next IP address, 22. Since 22 is subnetted mask with 0, the result is 0. So your problem is only here now. So what is 17? 17 is 16 plus 1. So meaning 1, 0, 0, 0. That is 1, 2, 4, 8, 16. So we turn on these numbers here, 32, 64, 128. So that is our 17. How about 248? 248 is 128 plus 64 plus 32 plus 16 plus 8. That's 248. Then the rest are 0. So if we are going to perform AND here, that would be 0, 0, 0, 0, 1, 0, 0, 0. So where does this IP address falls? It falls on the 16th, 1, 2, 4, 8, 16. So meaning this IP address 158.200.17.22 is at network 158.200.16.0. Very short, right? Very fast. Okay, I hope you get that idea. Aside from the network address, we are going to look also for the broadcast address of a particular IP. And it's very, very important. You have the beginning and you have the end, so that you may know that the in-between IP addresses are useful. These two addresses are not useful because they are the father and the mother, as for me, no? That's what I explain to my students, but where this IP came from and where will it end IPing? Where are you going to stop IPing? At the broadcast. So that's why we have to look for the broadcast. So a broadcast address is a special internet protocol address used to transmit message or data packets into the system. The broadcast address was designed to facilitate message broadcasting for all the devices. If you're going to use the announcement analogy, it's just like broadcasting. If all of the channel points to ADDRESSING and ADDRESSING is broadcasting its program, all person or all TV set pointing to that channel will receive the information. So that is what we call broadcasting. So if you are not part of that particular network, you cannot hear. If your channel points at GMA, meaning you cannot hear what ADDRESSING is broadcasting. Okay? So usually broadcast address is the last address of the IP in a particular network. So if that network is 200.15.18.0, so basically this is a class C, right? So if it is a class C, it starts with 0 and it always ends with 255. So meaning this number now is your broadcast address. That's very, very simple. If it is a class B, take note. Class B is n.h.h. Since this is an IP, okay, what would be the last IP address? So take note, if it is an N, all H's should be 255. The last is 255. That makes it broadcast. That's why we convert N is 190 because we cannot change it. 13 is an N, that's why we cannot change it. But this one is still part of your network. It hasn't reached 255 yet. Therefore, it's an IP. So if we are going to push through until it reaches 255, we call that one as broadcast. I hope it is clear, and we are going to give another example. Example 120.15.0.18. So we know that this is class A. So class A address is N. So we are referring to N.H.H.H. So take note, if these numbers here does not reach 255, it's still an IP. If it is still 0, it's still a network. So therefore, you are going to make this all 255, okay, and retain the 120 because it's a network. So meaning 120.255.255.255 will be the broadcast address of this IP. So how to identify the broadcast of an IP? There is a process, and you have to go through the process so that you can understand why. But you have to go through the process, it is much better because you understood what the process and the procedure is. So number one is using the following method when identifying the broadcast of a given IP and a subnet. You convert the number into its binary form, perform operation from left to right to left, depends to you. If the subnet masks are all ones, copy. That's what we did a while ago. And if the number of masks is not 0, convert the IP address binary into ones, then copy that value as your answer. Example, if all the subnet masks are all ones, you are going to copy the result. 11,000,110 dot 0,0,0,111 dot 11,0,0,1,0,0,0. We just copied because all of the subnet masks are ones. But it said there, if the subnet masks are not ones, convert the IP address binary into ones, then copy the value as your answer. Now, the subnet masks here are not ones, meaning it is 0. Convert all of this to become 1. All of these are ones. Then bring it down. 1, 2, 3, 4, 5, 6, 7, 8. That is your answer. So this one is still 198.15.200.255. So it's very easy. Next, we go to process. If the subnet masks are all ones, just copy the IP address, octet. So in this case, this one are ones. So we'll just copy the IP 01010101 dot. Since the subnet masks are not ones, it said that you are going to convert all of this IP here, all of these numbers here to become 1. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And bring it down. 1, 2, 3, 4, 5, 6, 7, 8 dot 1, 2, 3, 4, 5, 6, 7, 8 dot 1, 2, 3, 4, 5, 6, 7, 8. That will be your answer. So if you are going to convert that back into decimal form, this is still 85. And 111 are all ones are 255. 255.255. So that means that 85.9.78.121 is broadcast address. And last, 192.35.87.211. But take note, the subnet mask is different, the 224. So again, you just copy 1111 0000000 because it said that if all subnet masks are 1, bring down all the IP address 00011 dot. The subnet masks are all ones, you are going to bring down the number. If it is 0, make all that number ones. So meaning that is 0, okay, 1, 0. And since these are all 0, we are going to make this one as 1. So meaning 1, 2, 3, 4, 5 dot. Since these are all 0, we are going to make this ones and bring it down. 1, 2, 3, 4, 5, 6, 7, 8. Now, let's convert this back to its decimal value. This is 192. This is what? 35 still. Dot. Oh, we are going to compute it. 64168421. Okay, we'll compute what is this value. So that is 4 plus 6, that's 10, 18, 22, 24, 25. 5, carry 2. So 6 plus 2, that's 8. So meaning this is 85.255. That means that this IP address has a broadcast of 192.35.85.255. So that means we have computed the correct values here. So any questions so far? You comment this one and you're going to give me a thumbs up and tell your classmates and your friends. Okay. Let's learn networking from Sir Godwin. How about let's do IP addressing in packet tracer. Let's say, for example, IP addressing is basically on the local area networking part. So we are going to implement different styles so that you may know how to implement IP addresses statically and dynamically. So here, I have several PCs here. Then we are going to connect it to the switch. Then we'll put an IP address onto it. First that we are going to do is we are going to make it static. Let's try to use the address of 198.11.200.0 network. And we know this is a class C, therefore, the subnet mask is 255.255.255. And take note, starting IP address, by best practice, you start with .10, not .1. Because in the best practice management of IP addressing, IP addresses that is .1 to .9 are intended for administrative purposes. That's why .1 will always be the gateway. The .2 IP address given for switches. The .3 may be your server. .4 may be printer or any other devices. So it's up to you. But for me, I start always with 10. That's why we're going to pull this one up. Then the desktop, go to IP configuration, and we are going to type our IP address. So that's 198.11.200.10. Copy. Then subnet mask is the same. The default gateway is .1. So go to PC number 2, go to desktop. This one IP configuration, and just copy. This is 11. Subnet mask is the same. Then this will be their default gateway. Same is true with computer number 3. This is 12. And this is 1. This will be 13. You cannot have the same two IP address. IP addresses are unique. So if you have two the same IP address, your computer will not accept it. So basically, we have IP'd all the PCs here. So when you are going to test whether that IP is working or not, all you have to do is to ping them by using the PDU protocol data unit here. You click it, then you point to the source and to the destination. Point to the source and to its destination, successful. Source, destination. All the PCs can communicate because of the IP address. So again, we can also use what we call DHCP. Let's try to do this. Same IP address, but we are going to use a server in a different setting. 1, 2, 3, 4, 5, 6. Then we're going to pull up our switch. Okay, and in that switch, I'm going to also add a particular server. And that server will be our DHCP. So this one, I'm going to put it at gigabit 01, then all of this will be 1, 2, 3, 4, 5, and 6. Okay, so the first thing that you're going to do is configure your server. And we are going to make sure that the IP address of the server, look at this one, will be statically configured. That's why go to desktop, you go IP configuration, then 192.11.200.3, because 3 points at the server. Same subnet mask, the default gateway will be .1, and you can also put the DNS server if you like. The DNS server is the IP address of our server. So once this is already done, you go to your services, you go to DHCP, and this time you turn it on. You name your DHCP. Let's say, for example, this is LAN1-DHCP. What is our default gateway? .1. What is our DNS server? It is .3. And we start our IP addressing with .10. If you're going to put .100, so meaning it will start .100. The subnet mask is still the same. The maximum number of users is 255. If your server has this maximum number of users, these are the IP addresses that it will give to each PC. If you put only 2 here, so other PC can have an IP address because you only allocated at least 2 IP address for these computers alone. So take note of that always. Then we will add. Once you add, this server pool here is the default. That's why if you are not going to change the value of this one, your computer will ask for the IP address here rather than our created LAN pool. All we have to do is to click this one, then we will make it 0. So when you say maximum number of users 0, so it cannot give out IP addresses anymore. We save. That's it. Simple as that. Or if you would like to, just make this subnet mask 0, all of them, IP address 0, then you save, so that there will be no chance for this server pool to give out IP addresses. Close this, you go to your PC, you go to your desktop, IP configuration, but instead of static, you go to HCP. Then there will be communication between the HCP and the PC. That's why it gives out the correct IP address now. So this one will be created the same process. Wait for a couple of seconds. There, this one also. There you are. There you are. There you are. And let's say, for example, for the sake of an argument, I will be giving you an example here. Let's say we will add another PC. you don't have to rewrite again that IP address. All you have to do is to connect it to the switch. Now, if you are going to ask for an IP address, HCP, it will give you what we call a PIPA. Why? Number one, if you look at your switch, it's connected, it's still orange. Therefore, your server cannot give out the IP address yet. You are given 169.254.9240. So it means that your PC cannot communicate with the server yet. That's why you are given an APIPA. APIPA is an automatic private IP addressing, and that IP address starts with 169. So you don't have to panic. But later on, when this PC and this switch can communicate now with the server, automatically you are given a correct IP address. Until now, it's still communicating. And if you want to wait, then you wait. But if you don't want to wait, then you click static, then you click dynamic, then automatically it will give you the correct IP address. If this computer has not able to communicate or establish connection to the switch, therefore it cannot see the server. The server also cannot give out the IP address because it thinks that this connection here is not working. That's why you have to make it work, or you have to fast forward it. If it's green already, then therefore the communication lines are open. That way you can receive your own IP address, and that is IP address. Now, in Packet Tracer, the manner of configuring it in Packet Tracer is different from the manner you are configuring it on your PC. Now, on your PC, it says there, if you can see, there is an icon here that says a network. You right-click it and open network and internet settings. Now, from there, you go to the Ethernet, then you go to the network, you go to the network sharing, you go to this Ethernet, or you go to that adapter setting, it doesn't matter. You click. Once you click, you go to the properties, you go to the IPv4, get its properties, then you can change the IP address now. That's how we change IP address in our PC. So if you do the same in the other computer, computer A and computer B can communicate now because they are of the same network, their IP address are unique, and they have the same subnet mask. So that would be it. So thank you, and I hope you learned something today. Goodbye.